In this problem, we want to calculate the volume delimited by a paraboloid given by the equation 2az equal to x squared plus y squared, where a is just a constant, and the sphere. So it's also delimited by a sphere whose equation is x squared plus y squared plus z squared, so it's centered at the origin, equal to 3a squared. And the volume is the inner volume of the paraboloid. So we have a paraboloid like something like this. So I will just do a very quick sketch, and then we close this paraboloid with a portion of sphere. So we have a portion of the sphere here given by that equation, and also the paraboloid here. And we want to calculate the volume inside this paraboloid and the sphere. So what I want to do here, I want to use cylindrical coordinates. So it will be easier to calculate this integral if we use cylindrical coordinates. X equal to rho cosine theta, y equal to rho sine theta, and then z is just equal to z. It will just remain equal to itself. We are not going to change z. So the equation for the paraboloid will become 2az equal to rho squared, whereas the equation for the sphere will become rho squared plus z squared equal to 3a squared. Then, if we want to calculate the volume, we need to calculate the triple integral, and we also have a Jacobian when we go to cylindrical coordinates, so a factor of rho will appear inside the integral, and then I will start with dz. So I will integrate over dz, and then over d rho, and then over d theta. And now we have to insert the limits of integration. The limits for theta are very simple because we start from 0 and then we go all the way to 2 pi. Whereas the limit for z can be easily obtained because we start from the paraboloid and then we have to move all the way up to the sphere, like this. So we have to use these two equations. We start from the paraboloid, so from this equation here, we can obtain z equal to rho squared over 2a. So the integral over z starts at rho squared divided by 2a, and it goes all the way up to square root of 3a squared minus rho squared, which is something that you can obtain from here if you find the expression for z. Whereas, what about rho, the limit for rho? Well, rho will go from 0 because at the origin rho will be equal to 0, because remember, rho is the distance of the points contained inside this paraboloid from the axis of the paraboloid, which is also the z-axis. So the greatest value that rho can take is this one up here, where the paraboloid intersects the sphere, right? So how do we find that maximum value that I will call r, capital R here? Well, we can find it by using these two equations. We can substitute, for example, z equal to rho squared over 2a into this one, and instead of writing down a rho, I will write capital R, which is the value that we want to find, so we get r squared plus, then we have r squared over 2a squared equal to 3a squared. This is an algebraic equation that we can easily solve for r, and the value that you can get is r equal to square root of 2a. You can see very easily that r equal to square root of 2a will solve that equation. And therefore, this integral will give me, now I can substitute r equal to square root of 2a, and this will give me 2 pi, so I can integrate over theta because the integrand does not depend on theta. So I have a factor of 2 theta there, integral from 0 to square root of 2a, and then if I integrate rho over dz, so that's just a constant, right? So I have rho times z, and then I have to evaluate z between the two limits of integration. So I have rho times the square root of 3a squared minus rho squared minus rho cubed divided by 2a d rho, and this is equal to 2 pi times, I can rewrite the integral like this: 1/2 integral from 0 to square root of 2a, then I have the square root of 3a squared minus rho squared d rho squared minus, and here I have square root of 2a to the fourth power divided by 8a. If I integrate the second term, I will get that, and then I can also integrate very easily this first term. So I have this is equal to 2 pi 1/2, and then I have minus 2/3 3a squared minus rho squared to the 3/2, and evaluate it between 0 and square root of 2a minus a cubed divided by 2. I can also use curly brackets here if I want to be precise, but it's not really important. And this is equal to, so I can cancel these factors of 2 here, and then I get pi minus 2/3 a cubed plus 2/3 3 to the 3/2 times a cubed minus a cubed, and this is equal to pi over 3 minus 5 plus 2 times 3 to the 3/2 a cubed, and this is also equal to, so you can rewrite 3 to the 3/2 as 3 square root of 3, so you get that this is equal to pi over 3 6 square root of 3 minus 5 a cubed, and this is the result of the integral.